Hello students, today I am doing class for class 12 science. The subject is mathematics and the topic is determinant. In the last class also we were doing the same topic, determinant, right? So today also I am continuing the same topic, that is determinant. So let's do some problems. So now this is again exercise 2B. Each question carries 5 marks. Page number is 177 and this is question number 28. And in the last class we did question number 26, right? So let's do question number 28. So if A, B, C are real numbers, real number means not imaginary, that is they are defined numbers, right? Such that this determinant is given. That is, what is the first row here? This is the third order determinant. B plus C plus A plus B. What is the second row? C plus A plus B plus C. What is the third row? A plus B plus C, and C plus A, which is equal to 0. Now you have to prove that either A is equal to B is equal to C, or A plus B plus C is equal to 0. Now let's do this problem. So let's do it from given here. So what is given here now? So let us write down given. So you have to prove here either A is equal to B is equal to C, or A plus B plus C is equal to 0, right? So now you have to write down this given again. Write down this given again. Now you have to simplify it. So you have to simplify it in such a way that it should be in the simplified form. Then only you can do the problem. Okay, so let's apply some properties here. That is property number 5. Some properties means property number 5. So if you do R1 plus R2 plus R3, what do we get? R1 plus R2 plus R3, 2A plus 2B plus 2C. This is also 2A plus 2B plus 2C. This is also, if all the terms of the third column are added, then you will get 2A plus 2B plus 2C. That means we are getting the same elements in the first row. So you can apply it in column also. What is C1 plus C2 plus C3? This also, if you add all these terms in the third row, what do we get? 2A plus 2B plus 2C. Similarly, add all those terms in the second row, 2A plus 2B plus 2C. Similarly, add all those terms in the third row, you will get 2A plus 2B plus 2C. That means we are getting the same elements in the first column. That is twice A plus twice B plus twice C. Again, there is common there. That is, what is common here? 2 into A plus B plus C. So let's do, you can apply the properties with respect to the rows or with respect to the columns, right? So let's apply property in column 1. That is C1 dash is equal to C1 plus C2 plus C3. You may apply property in row wise also. With respect to row wise also, you can use the property number 5. Okay, what is C1 dash is equal to C1 plus C2 plus C3. So, or now it will be, if you add all these terms in the first row, you will get, isn't it, 2A plus 2B plus 2C. Again 2 is common there. 2 into A plus B plus C. Again all these terms are added in the second row. Again it is 2A plus 2B plus 2C. 2 is taken common. A plus B plus C. Again all the terms in the third row are added. 2A plus 2B plus 2C. 2 is common here. So it is A plus B plus C. Is that clear? And now second column and the third column remain same. This is C plus A plus B, B plus C, then comes third row also remains same, A plus B, B plus C, C plus A, which is equal to 0. Okay, but now from the first column you only take 2 common. Khali hami 2 matra common nikalchau, not A plus B plus C. You don't take common twice into A plus B plus C, but take only 2 as common. So let us take it outside, only 2, okay, or 2. Now what is the first column? A plus B plus C, A plus B plus C, then again it is A plus B plus C, right? Now what is the second column? Second column remains same. That is, it is C plus A plus B, A plus B and B plus C. Next, third column, A plus B, then comes what? B plus C, then it is C plus A. C plus A, which is equal to 0. Okay. So let us make this determinant more easier by using properties again. That is property number 5. So now you can make these two terms here as a single term. You can make this C plus A as a single term, A plus B and B plus C as a single term by using property number 5. That is, if you do C2 dash is equal to C2 minus C1. Okay, so C plus A minus C minus A gets cancelled, you get only B, minus B is there. Again A plus B minus A minus B minus C minus C is there. Again B plus C minus B minus C minus A, only minus A is here. Similarly, in this case you can change that third column also. Third column ma pani हामी यसलाई single element ma नै change गर्न सक्छौं. कसरी भन्दा पनि you can use the property C3 dash is equal to C3 minus C1. So A plus B minus A minus B minus C, only minus C remains here. Now this is 2. 2 is taken common here, isn't it? But you know that 2 not equal to 0, isn't it? So you don't have to write 2 here. Okay, because 2 is not equal to 0. So now, or you can write A plus B plus C, C plus A plus B. Next, A plus B plus C, A plus B, B plus C. And this is your A plus B plus C, B plus C. And this is C plus A is equal to 0. So now we have to convert all these elements into single elements now by using the properties here. That is, if you do C2 dash is equal to C2 minus C1. C2 minus C1. C plus A minus C minus A, that is, you will get minus B here. Similarly, A plus B minus A minus B minus C, you will get minus C here. B plus C minus B minus C minus C, you will get minus A here. Okay? So we can use here C2 dash is equal to C2 minus C1. Again, you can use C3 dash is equal to C3 minus C1 also. If you do C3 dash is equal to C3 minus C1, what do we get? A plus B minus A minus B minus C, you will get minus C here. Here also B plus C minus B minus C minus A, that is minus A is here, right? C plus A minus C minus C minus B is here. That means we are converting all these elements in the second column and in the third column into single elements. Okay, so let's use the property now. The property here is C2 dash is equal to C2 minus C1 and C3 dash is equal to C3 minus C1 again, right? So now, therefore, first column remains same, A plus B plus C, A plus B plus C, this is also A plus B plus C, right? Now what is C2 minus C1? Column 2 is changing. C plus A minus C minus A minus B, so here it is minus B. Similarly, what will be the second element of the new second column? A plus B minus A minus C. Minus A minus B minus C. A, B gets cancelled, you will get minus C. And next one, B plus C minus A minus B minus C. B, C gets cancelled, you will get minus A. Right? Now C3 dash. C3 dash means column 3 is changing. That is, how does it change? C3 minus C1. Right? So A plus B minus A minus B minus C. That is, it is minus C. B plus C minus B minus C minus A. That is, it is minus A. C plus A minus C minus B, that is, it is minus B, which is equal to 0. Is that clear now? Again, you can make the elements here. In the first column, you can make or you can convert these elements in the first column into single elements by using the property C1 plus C2 plus C3. So why are we doing so? Because if you do C1 plus C2 plus C3, this BB gets cancelled, CC gets cancelled, you get only A. Here also CC gets cancelled, A gets cancelled, you get only B here. If these are added, A gets cancelled, BB gets cancelled, you get only C. So let us use C1 dash is equal to C1 plus C2 plus C3. C1 dash is equal to C1 plus C2 plus C3. Let's use this property now. So next, or now C1 plus C2 plus C3, that is column 1 is changing. A plus B minus C, BC gets cancels, you will get only A. Here also A plus B plus C minus A. AC gets cancelled, you will get only B. A plus B plus C minus B, A gets cancelled, BB gets cancelled, you will get only C. Okay. Then second column and the third column remain same. Minus B minus C minus A minus C minus A minus B, which is equal to 0. Is it clear now? Now what will you do in the next step? You can take minus common from the second column and from the third column. So if you take minus common from the second column, you will have minus sign in the front, that is in front of determinant you will have 1 minus. Again from the third column you take minus common and you should write it outside determinant. So minus into minus plus. So minus into minus will be plus. From the second column minus sign is taken common. From the third column minus sign is taken common. So or what do we get? It is minus into minus. Minus into minus. Okay, what is the first column? A, B, C. What is the second column? It is B, C, A. What is the third column? C, A, B. C, A, B. Determinant sign closed, which is equal to 0. Okay. So, yeah, agadi ke bha minus into minus, that is always plus. But usually we don't write this plus sign. So now we can expand this determinant easily, isn't it? Because there are single elements in each row and each column. Let us expand it. So now let us expand it with respect to the first row. Okay? Let us expand it with respect to the first row. What is the method? Plus minus plus. So A within bracket, delete the row and the column through the element A, that is first row and first column are deleted. C A, A B remain. C into B, B C minus A square. Then comes minus B, delete the row and the column through the element B, that is first row and second column are deleted. B A C B, B into B, B square minus C A, right? Then comes plus C, right? Plus C, that is the third element from the first row, plus C. Now delete the row and the column through the element C, that is A, B, C, first row is deleted, then third column C, A, B is also deleted. So what remain? B, C, C, A. Now cross multiply B by A, so it is A, B, B minus sign I, C to C what? C square. So which is equal to 0. Is it clear now? So now let us simplify it once again. Now we can multiply it, or multiply by A. This is ABC, plus or minus minus A cube, right? Then minus B cube, minus into minus plus ABC, then plus multiply by C there, ABC, plus or minus minus, this is C cube, which is equal to 0, right? So now, or this is minus A cube, minus B cube, minus C cube, plus ABC, plus ABC, plus ABC, what is it? Plus 3ABC, which is equal to 0. So now what will you do? Now you can take minus common here, or minus is taken common. A cube plus B cube plus C cube minus 3ABC, which is equal to 0. Now here minus is taken common, isn't it? So within bracket what do we have? A cube plus B cube plus C cube minus 3ABC bracket close, which is equal to 0. Actually minus 1 is taken common, isn't it? But in this case, minus 1 not equal to 0 again, isn't it? Minus 1 is not equal to 0. So you don't have to write this minus sign. So what do we get? A cube plus B cube plus C cube minus 3ABC, which is equal to 0. Okay. Now there is a factor formula for this expression. Okay, so what is the factor formula for this expression? I told you one day about the factor formula of this expression, isn't it? So what is it? It is a plus b plus c into a square plus b square plus c square. Next one is minus ab minus bc minus ca bracket closed, which is equal to 0, right? Is equal to 0. Okay. So next, what will you do? So in the next step, since this left hand side is equal to 0 and these are the two factors, either first factor is equal to 0 or second factor is equal to 0. So you can write either a plus b plus c is equal to 0 or a square plus b square plus c square minus ab minus bc minus ca is equal to 0. Okay. So we have proved the first part, that is a plus b plus c is equal to 0 is proved. You have to prove there, you can check the question, we have to prove there a plus b plus c is equal to 0. So this is the first part which is proved. Okay. Now we will prove the second part, that is, what is the second part there? A is equal to b is equal to c. So we can prove a is equal to b is equal to c from this equation. Okay. Now what is there on the left hand side? It is a square plus b square plus c square minus ab minus bc minus ca. So now there is ab, let us multiply it by 2. This is bc, let us multiply it also by 2. And there is also ca, let us multiply it by 2. So if you multiply these three terms by 2, you should multiply a square plus b square plus c square also by 2. If you multiply left hand side by 2, you should multiply right side by 2. That is, you have to multiply both the sides by 2. So why are we multiplying both the sides by 2? To convert it into the form of a square minus 2ab plus b square form, which is equal to a minus b whole square. Okay. So now write on multiplying both the sides by 2, right? So therefore 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca is equal to 0, right? So now for this minus 2ab we need a square plus b square, so that you can use the formula a square minus 2ab plus b square, which is equal to a minus b whole square, isn't it? Also for 2bc, what do we need here? B square c square. For 2ca, what do we need? C square and a square. So where can we take that from? We can take that from 2a square, 2b square and 2c square. So let us separate. Let us break this term, 2a square, 2b square, 2c square. So how can you write 2a square? A square plus a square, right? You can write here a square plus a square. What is 2b square? B square plus b square. What is 2c square? C square plus c square. Then write down minus 2ab minus 2bc minus 2ca, which is equal to 0. Okay. So I think we have understood it. You can copy it. Now let's simplify it. Now for this minus 2ab we need a square b square. So you can write this a square b square. Okay. So within bracket you write a square minus 2ab plus b square. Now again for this minus 2bc we need b square and c square. So this b square minus 2bc plus c square. Let us write down these three terms now. That is plus b square minus 2bc plus c square plus again. So look at the blackboard. Here are unmarked terms. That is for minus 2ca we need c square and a square. So let us write down these three terms now. That is c square minus 2ca plus a square bracket closed, which is equal to 0. Is it clear? Now these are all the formulae: a square minus 2ab plus b square. What is the formula in this case? A minus b whole square plus, what is the formula here? It is b minus c whole square plus, what is the formula there? It is c minus a whole square, which is equal to 0. Okay? So now we have to understand this equation. It says that a minus b whole square plus b minus c whole square plus c minus a whole square is equal to what? 0. It should be exactly equal to 0. When is this equation possible now? So whatever may be the values of a, b and c, okay, a minus b whole square is always a positive quantity, because plus whole square is also a positive quantity, minus whole square is also a positive quantity. Suppose a is greater than b, a minus b is positive, positive whole square is positive, right? Also, if a is less than b, if a is less than b, then a minus b is negative. What is negative whole square? It is positive. So a minus b whole square is always a positive quantity. Similarly, b minus c whole square is also a positive quantity. Similarly, c minus a whole square is also a positive quantity, right? So positive quantity plus positive quantity plus positive quantity is not equal to 0. Positive quantity plus positive quantity plus positive quantity कहिले पनि 0 हुँदैन. यो चाहिँ कति बेला 0 हुन्छ भन्दाखेरि if this individual values within whole square is equal to 0. That means this equation is possible if a minus b is equal to 0 and b minus c is equal to 0 and c minus a is equal to 0. Is that clear to all of you? So you have to understand it. Okay, so you write this equation is possible if a minus b is equal to 0 and b minus c is equal to 0 and c minus a is equal to 0. Is that clear? So from here we get a is equal to b, and from here b is equal to c, and minus a is taken to the right hand side, so it is c is equal to a. So let us combine all these three relations. A is equal to b and b is equal to c and c is equal to a. What do we write? A is equal to b and b is equal to c and c is equal to a. What can you write? It implies that a is equal to b is equal to c. So we have proved this result, that is a is equal to b is equal to c. Okay? So let's write either we had proved a plus b plus c is equal to 0, and just now we proved that a is equal to b is equal to c. So it is proved. Is it clear to all of you? So you can copy it. तिमीले घरमा यो राम्रोसँग प्र्याक्टिस गर्नु, बुझ्नु, बुझ्यो? बुझेन भने you can comment me or you can phone or you can call me. Okay? So this is the answer. So let's do next question now. Now we will do question number 29. You have to prove that this determinant is equal to 0. That is, this is the third order determinant. What is the first row? A square plus b square by c, c, c. Second row, a, b square plus c square by a. What is the third row? First element b, second element is also b. What is the third element? C square plus a square by b. So let us prove this determinant is equal to 4abc. Okay? So let us write down the left hand side as d is equal to. Suppose this is d is equal to left hand side. You have to prove left hand side is equal to 4abc. Is it clear now? So let's simplify it. Since in the first term, that is in the first row, we have a square plus b square by c. Let us cancel this c. So if you want to cancel this denominator c, you should multiply it by c. If you multiply the first term by c, you should multiply second term and third term by c as well. Isn't it? Here also in the second row, similarly in the second row there is a, you should cancel it. It should be multiplied by a. So this first and the third term are also multiplied by a. Okay. In the third row, there is b here in the denominator. In the third element, in the denominator, there is b. You should cancel it. You should multiply it by b. If you multiply this third element by b, you have to multiply this first and the second element by b also. Isn't it? You have understood what I mean to say? So we are multiplying the first row by c, second row by a, third row by b. We are multiplying ourselves, but you have to cancel that one also. So what should we write outside determinant? 1 upon ABC. Clear? So write down. Therefore, D is equal to, this is 1 upon ABC. Is that clear? Now you can multiply all the terms of the first row by C. What do you get? CC gets cancels. This is A square plus B square. Then comes C into C, C square. Then C into C, this is C square, right? So this is the first row. Next, you multiply all the elements of the second row by A. So what is A into A? A square. Multiply by A here, A gets cancels. B square plus C square. A into A is, here it is A square. Is that clear? Next, what will you do? Multiply all the elements of the third row by B. What do we get? It is B square, and this one is C square plus A square. Is that clear now? So now let us use properties of determinant. So what will you do here now? So now if you do R1 minus R2, R1 dash is equal to R1 minus R2. Let's see what happens. A square gets cancelled, B square. Here C square gets cancelled, we get minus B square, and this will be C square minus A square. It will be quite easier, isn't it? Similarly, R2 dash is equal to R2 minus R3. Let's check it. What happens here? A square minus B square. Here B square gets cancelled, we get C square. And there A square gets cancelled, we get minus C square. Right? So let us use the property here. R1 dash is equal to R1 minus R2. And what? And what? R2 dash is equal to R2 minus R3. And next, R2 dash is equal to R2 minus R3. Is that clear? So we will use these two properties now. Okay? So what will be in the next step? So therefore D is equal to 1 upon ABC. Now R1 dash is R1 minus R2. This minus this. A square gets cancelled, you get B square now. Then again R1 minus R2, C square minus B square minus C square gets cancelled, you will get minus B square. Next, this is C square minus A square, right? So C square minus A square. So I think you have understood this new first row. Similarly, what is the new second row? Can you tell me what is the new second row? R2 minus R3. That is A square minus B square. Let us write it here. A square minus B square. Right? Next, B square plus C square minus B square. B square gets cancels. You will get C square again. A square minus C square minus A square. What do we get? A square gets cancelled, we get minus C square. Is that clear? And third row remains same. So B square, this is also B square, then C square plus A square. C square plus A square. So I think you have understood it. So let us simplify it once again using the property number 5 again. So now what will you do? This B square minus B square will be 0. That means R3 plus R1. If you do R3 plus R1 or R1 plus R3, you may do R3 plus R1 or R1 plus R3. Let's do R1 plus R3. Let us change the first row. So how does it change? R1 plus R3, B square plus B square, 2B square, minus B square plus B square. This is 0. C square, 2C square, and this minus A square plus A square gets cancels. Isn't it? So right now, let's use R1 dash is equal to R1 plus what? R3, right? So therefore D is equal to 1 upon ABC, right? Now row 1 is changing, new row 1, how does it change? R1 plus R3, B square plus B square what? 2B square minus B square plus B square, 0. C square minus A square plus C square plus A square. What is it? A square gets cancelled. You will get 2C square. Is it clear? Next, second row and third row remain same, right? So it is A square minus B square. This is C square minus C square. Next, B square, and this is C square plus A square. So this is the new determinant, right? So now what will you do in the next step? What will you do in the next step now? Now you can take common from the first row. What is common out there? 2. So let us take it outside. D is equal to 2 upon ABC. What is the first row? B square, 0, then it is C square, right? What is the second row? A square minus B square, then C square minus C square, it remains same. Third row also remains same. B square, and then what? C square plus A square. Is it clear now? Now again you have to use the properties. Don't expand it. Again you can use the properties in this case, isn't it? So how can you use the property? Let's simplify R2 and R1. If you do R2 plus R1, that means row 2 is changing, isn't it? A square minus B square plus B square, A square. C square plus 0, C square. Minus C square plus C square, it is 0. It is quite easier, isn't it? Similarly, if you do this R3 minus R1, B square minus B square, 0, B square minus 0, B square, this is C square plus A square minus C square, this is A square. It is quite easier, isn't it? So let us do R2 dash is equal to R2 plus R1. In this case, you will do R2 dash is equal to R2 plus R1, right? R2 dash is equal to R2 plus R1, right? And what is R3 dash? R3 dash is equal to R3 minus R1. In this case, it is R2 dash is equal to R2 plus R1, but in row 3 dash, you should do R3 minus R1. Is that clear? Next, therefore, D is equal to 2 upon ABC. Now, row 1 remains same. That is B square, 0, C square. What is R2 plus R1? A square minus B square plus B square. That means only A square is there. C square plus 0, C square. Minus C square plus C square, that is 0. That is R2 plus R1. That is row 2 is changing here. Next, what is R3 dash is equal to R3 minus R1? That is B square minus B square, 0. B square minus 0. B square minus 0 is B square. And what's about C square plus A square minus C square? It is only A square. This is quite easier, isn't it? Now you can expand it. Now you can expand it with respect to the first row or second row or third row, or it may be first column, second column and third column, so that you can get the answer, that is, which is equal to, what was the answer? Which is equal to, I think it's 4ABC, I think, isn't it? So now, let us expand it with respect to first row. The answer should be 4ABC, right? So let us expand it with respect to the first row, right? So therefore, D is equal to 2 upon ABC. Now within third bracket. Let us expand it with respect to the first row. That is B square, 0, C square, right? So now it is with respect to the first row, B square, 0, C square, plus minus plus. So it is B square within bracket. Delete the row and the column through the element B square. That means first row and first column are deleted. What remain? C square 0, B square, A square. So it is C square into A square, C square, A square, right? Then minus 0, right? Minus 0. Next, will you write minus 0? No, because 0 into any number is always 0. Okay, you don't have to write 0. Then comes plus C square. Plus C square. If you consider this element C square, you have to delete the row and the column through the element C square. That means first row and third column are deleted. What remains? A square, C square, 0, B square. Now multiply, cross multiply A square by B square. What do we get? A square, B square. It is A square, B square. Then minus. Then comes minus sign first. So 0 into C square, 0. So it is minus 0. Third bracket is closed. So this determinant is expanded. Okay. So therefore D is equal to 2 upon ABC. Now write down within bracket, multiply them. B square into C square, A square, B square, C square, plus again C square into A square, B square, that is A square, B square, C square. Is that clear? So therefore D is equal to 2 upon ABC into, what is A square, B square, C square, plus A square, B square, C square, that is twice 2A square, B square, C square, right? So let us simplify it. A and E square gets cancels, B and E square gets cancelled, C and E square gets cancels. So what is D is equal to now? This is 2 to the 4. It is ABC. So which is equal to right hand side. So it is proved. Proved. Okay. So in this way you can do this problem. You can copy it now. Now we'll do the next question again. Now we will do the next question, that is question number 30. Here also you have to prove that this determinant is equal to 1. That is, what is the determinant here? Third order determinant is there. What is the first row? 1, 1 plus A, 1 plus A plus B. What is the second row? 2, 3 plus 2A, 4 plus 3A plus 2B. What is the third row? 3, 6 plus 3A, then 10 plus 6A plus 3B. Okay, that is the determinant, given determinant. You have to prove is equal to 1. So let us write down the left hand side as given determinant D. Again you write down the determinant D is equal to this one, write down. So D is equal to this one, right? Now how will you simplify the determinant? Using properties. Now in the first column there are 3 numbers, 1, 2, 3. If you write 2 minus 1, that is R2 minus R1. R2 dash is equal to R2 minus R1. You will get 2 minus 1 is 1 here. Similarly, what is R3 minus R2? R3 dash is equal to R3 minus R2. That means row 3 is changing. How does it change? 3 minus 2 is 1 here also. Isn't it? So let us use the property. R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R2. Right? R2 dash is equal to R2 minus R1, that is row 1 is changing. How does it change? R2 minus R1. R3 dash means row 3 is changing. How does it change? R3 minus R2. Right? So let us write down. So D is equal to, so first row remains same, 1, 1 plus A, 1 plus A plus B. Now second row is changing. How does it change? 2 minus 1 is 1. 3 plus 2A minus 1 minus A. 2A minus A is A. And 3 minus 1 is plus 2. 3 minus 1 is 2. Right? 2A minus A is A. Plus 3 minus 1 is 2. Next. Again R2 minus R1, right? 4 minus 1 is 3. Plus 3A minus A is plus 2A. Plus 2B minus B is B. This is the new second row. So now what will be the new third row? How does it change? R3 minus R2. that is 3 minus 1, R3 minus R2, that is 3 minus 2 is 1, right? This is R3 minus R2, so it is 3 minus 2 is 1. 6 plus 3a minus 3 minus 2a. 3a minus 2a is a. And 6 minus 3 is plus 3. Is that clear? Next. Again, R3 minus R2, 10 minus 4. What is 10 minus 4? 6. Plus 6a minus 3a plus 3a plus 3b minus 2b plus b. So this is the new determinant. Okay, we are using the properties R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R2, and we got this simplified determinant. You have to prove here left hand side is equal to 1. Okay. So now let us simplify it again using the properties of determinant. Now there are 3 ones in the first column. You can make any two of these ones 0 by using the property R2 dash is equal to R2 minus R1. You may use R1 dash is equal to R1 minus R2 also. And R3 dash is equal to R3 minus R2 or R3 minus R1 like that. Right? So let us use R2 dash is equal to R2 minus R1. And R3 dash is equal to R3 dash is equal to, you may write R3 minus R2 or R3 minus R1. जुन चाहिँ लेख्दा पनि हुन्छ. Let us use R3 minus R2. R3 minus R2. Okay. Now D is equal to now first row remains same, that is 1 plus A and 1 plus A plus B. 1 plus A plus B, right? What is R2 dash now? It is changing, row 2 is changing. How does it change? 1 minus 1, that is R2 minus R1. 1 minus 1, 0. A plus 2 minus 1 minus A, that is A minus A is 0. 2 minus 1 is 1. Right? Then again 3 minus 1 is 2. Plus 2A minus A is plus A. And B minus B is 0. It is only 2 plus A now. What is R3 dash is equal to? R3 minus R2 now. This row 3 is changing. How does it change? R3 minus R1. R3 minus R1. 1 minus 1. 0. This minus this. A gets cancelled. 3 minus 2 is always 1. Again this minus this. What is 6 minus 3? 3. Plus 3A minus 2A. Plus A. And B minus B is always 0. So we get we get 3 plus A. So now you can expand it. Now you can expand it with respect to the first column, because in the first column 2 elements are 0 out here. So you can copy it, then we'll expand it. So now let's expand it with respect to the first column. So therefore D is equal to, we will expand it with respect to the first column. So what is the method here? Plus minus plus. So plus 1, you write plus 1. Now within bracket, delete the row and the column through the element 1. That is, first row and first column are deleted. What remains? 1, 1, 2 plus A, 1, 3 plus A. Now you have to cross multiply this 1 by 3 plus A first. So it is 1 into 3 plus A, 3 plus A. Bisma ke sign ayo? Minus. So what is now cross multiply 1 by 2 plus A? What is it? 2 plus A. But because of this minus sign, sign changes. That is minus 2 minus 2 plus minus A. Is it clear? So next, here A gets cancels. Therefore D is equal to 1 into, what is 3 minus 2? That is also 1. So D is equal to 1 ones are 1. Proved. That is left hand determinant is equal to 1. We have proved it. Okay. So you can copy it. Again, we'll do the next question. So now, we will do this question number 35. You have to evaluate. Evaluate means you have to find out the value of this determinant. So here the given determinant is This is the third order determinant. What is the first row? 1, 1, 1. What is the second row? 1 omega square omega. What is the third row? 1 omega omega square. So here in the question it is given that omega is an imaginary cube root of unity. So you have done it in class 11 in complex number. There is a chapter there, complex number. If omega is an imaginary cube root of unity or 1, unity means 1. Okay, so what is the formula? Omega cube is equal to 1 and 1 plus omega square is equal to 0. Is that right? So you should write down this formula first. Okay, since now this is the solution. Since omega is an imaginary cube root of unity, so therefore what can we write? Therefore omega cube is equal to 1 and 1 plus omega square is equal to what? 0. Right? Is that clear now? So now let us find out the value of this determinant now. So therefore D is equal, let us write this given determinant as D. So D is equal to, first row is 1, 1, 1, second row 1 omega square omega, what is the third row? 1 omega and omega square, right? So now you know that 1 plus omega square is equal to 0. So let us use the property here, that is, which property is used here? R1 dash is equal to R1 plus R2 plus R3. You may use C1 dash is equal to C1 plus C2 plus C3, okay? If you do R1 plus R2 plus R3, row 1 is changing. How does it change? 1 plus 1 is 3. 1 plus omega square. This is also 1 plus omega square. And you know that 1 plus omega square is always 0, right? Similarly, you may do C1 plus C2 plus C3. That means column 1 is changing. That is, what is C1 plus C2 plus C3? 1 plus 1 is 3. 1 plus omega square, which is 0. 1 plus omega square, which is equal to 0. So you can apply property either on the rows or on the columns. Is that clear? So let us use the properties with respect to the columns. So let us write C1 dash is equal to C1 plus C2 plus C3, right? So what is D now? D is equal now, first column is changing, right? 1 plus 1, what is it? 3. Next, 1 plus omega square. 1 plus omega square. Next, again, all the elements of the third row are added and it is written in the third element of the first column. What is it? 1 plus omega square, right? So now second column and the third column remain same. So it is 1 omega square omega. What is the third column? 1 omega. This is omega square. Is it clear to all of you? So you can copy it. And instead of 1 plus omega square, what do you write? You write 0 instead of 1 plus omega square. Because here we have written, if omega is an imaginary cube root of unity, omega cube is equal to 1 and 1 plus omega square is equal to 0. So write 0 instead of 1 plus omega square. Okay? So write it. So now it is, therefore D is equal to, so it is 3, 0, 0, 1 omega square omega, 1 omega, this is omega square. Is that clear? So now let us expand it with respect to the first column. Because in the first column, the two elements are 0 here. Okay? So let us expand it with respect to the first column. Therefore, D is equal to, now first column, we are expanding with respect to the first column, plus, minus, plus, so plus 3. Now within bracket. Now if you consider the element 3, you have to delete the row and the column through the element 3. That means first row and first column are deleted. What remain? Omega square, omega square. So cross multiply by omega square by omega square. What is omega square into omega square? omega to the power 4, right? Then comes what? Minus. Minus. Then you have to write omega into omega. What is it? It is omega square. Okay, now let us simplify it now. Therefore, d is equal to 3 within bracket. You know that if omega is an imaginary cube root of 1, then you can write omega cube is equal to 1. If omega is an imaginary cube root of 1, then you can write omega cube is equal to 1, isn't it? So omega to the power 4 can be written as omega cube into omega minus omega square. Therefore, d is equal to 3 within bracket. What is omega cube? It is 1 into omega minus omega square. Therefore, d is equal to 3 within bracket omega minus omega square, right? But now in this case, you should know the value for omega. So I think you know the value for omega. This is also done in class 11, isn't it? Can you tell me what is the value for omega? Omega value what you? That is the value for omega is equal to minus 1 plus I root over 3 divided by 2. That is the value for omega is always, it is defined as what? Minus 1 plus I root 3 divided by 2. This is the value for omega. But what is the value for omega square? Omega square will be minus 1 minus I root 3 whole divided by 2. So omega square is equal to minus 1 minus I root 3 whole divided by 2. So you have to remember this value, okay? So that is, what is the value for omega? Minus 1 plus I root 3 divided by 2. And omega square is equal to minus 1 minus I root 3 divided by 2. You do it up. Value से तिमीले याद गर्ने पर्छ. ठीक छ? So let us use the value here. So d is equal to 3 within bracket. What is the value for omega? Minus 1 plus I root 3 divided by 2 minus, what is omega square? Minus 1 minus I root 3 whole divided by 2. Right? Take sign. So now let us simplify it. Let us simplify it now. Therefore, d is equal to 3. D is equal to 3 within bracket. What's the LCM? The LCM is 2. This LCM 2 is divided by 2. That is 1. 1 into numerator minus 1 plus I root over 3. Similarly, this LCM is divided by this denominator 2. 2 ones are 2. That means 1 time. So 1 into minus 1 minus I root 3. But there is minus into minus plus. 1 into 1, 1. Then again minus into minus plus 1 into I root 3. This is plus I root over 3. Is that clear? पहिला यो LCM 2 लाई यो 2 ले डिवाइड गर्नु 2 1 are 2 1 time. So 1 into minus 1 minus I root 3 is minus 1 minus I root 3, but there is minus sign here. You have to change the sign. Minus into minus plus 1. Again minus into minus plus I root over 3. Okay? So you can cancel here. Minus 1 plus 1 gets cancelled. Right? So therefore d is equal to 3 into, what is I root 3 plus I root 3? 2I root 3. It is 2I root 3 divided by 2. Here 2 gets cancels. Or d is equal to, what is the final answer now? It is 3I root over 3. So this is the final answer. So what is the answer? What is the value of the given determinant? It is 3I root over 3. So this is an imaginary number, or this is known as complex number also. Is it clear? So you can copy it. अब हामी गर्दैछौं क्वेशन नम्बर 36. The question number 36 मा चाहिँ के छ त क्वेशन? If this determinant, that is the third order determinant, is given, minus a square ab ac, ab minus b square bc, ac bc minus c square is equal to lambda. This is a Greek letter. This is known as what? Lambda, right? Lambda a square b square c square. This equation is the given equation. You have to find out the value of lambda. So let us get the value for lambda now. Okay. So now let us write down this left hand side. Only you simplify first the left hand side. Okay. So we have written here d is equal to this third order determinant. Okay. So how do you simplify it? Therefore d is equal to, how do you simplify it? Now let's take common from the first row. There is a common. From the second row, b is common. From the third row, c is common. You can take common from the columns also. From the first column a, from the second column b, from the third column c. So let us take common from the first row, second row and the third row. Right? So ABC. From the first row is taken common. So it is minus a, b, c. Right? From the second row, b is taken common. A minus b, c. Right? From the first row, what is taken common? A. That is minus a, b, c. From the second row, b is taken common. A minus b, c. And from the third row, what is common here? C is common. Right? So it is a, b minus c. So is that clear to all of you? Okay. Next, what will you do? You can use the properties of determinant here. If you do R1 plus R2, R1 dash is equal to R1 plus R2, that means row 1 is changing. Minus A plus A 0, B minus B 0, C plus C is 2C. It is quite easier, isn't it? Again, you can do R2 dash is equal to R2 plus R3, A plus A 2A, minus B plus B 0, C minus C, that is also 0. Isn't it? So let's use the property R1 dash is equal to R1 plus R2. And next property is R2 dash is equal to R2 plus R3. Right? So let's use these properties. That means row 1 and row 2 are changing. So now, therefore D is equal to ABC. How does row 1 change? It is R1 plus R2, right? That is minus A plus A, 0, B minus B, 0, C plus C, 2C. Correct? Next. Now row 2 is also changing. R2 plus R3, A plus A, 2A. Next, minus B plus B, 0. C minus C, that is also 0. And third row remains same. That is A, B minus C. Is that clear? So now what we'll do in the next step? In the next step, from the first row, 2 is taken common. And from the second row, 2 is taken common. Is that clear? From the first row, 2 is taken common. And from the second row, also 2 is taken common. So it is 2 to 4. That is D is equal to 4ABC. Now what is the first row? 0, 0, C. What is the second row? A, 0, 0. What is the third row? Third row remains same. A, B minus C. Now, what will you do now? You can expand it. You can expand it with respect to the first row, isn't it? So, therefore, D is equal to 4ABC. Now, let us expand it with respect to the first row. That means, with respect to first row, 0, 0, C. That is, what is the method? Plus, minus, plus. Now, plus 0 will be there. Will you write 0? No, because 0 into any number always 0. Will you write minus 0? No, again 0 into any number is always 0. You don't have to write it, but you have to write C into C into C within bracket. Now we are taking this element C. You have to delete the row and the column through that element C. That means first row and third column are deleted. What remain? A0, AB. Now cross multiply A by B. We get AB, B square minus sign I have. Then cross multiply A by 0. What is it? A into 0 is 0 always. Therefore, D is equal. Now multiply them. It is 4 A into A square, B into B, B square, C into C, C square. So we get D is equal to 4A square, B square, C square. That is, what is the value of this left hand side? It is 4A square, B square, C square. Now, given here is, actually, we had assumed this determinant as D, isn't it? So this D is equal to lambda. So D is equal to lambda A square B square C square. Okay? But just now we got the value for D, isn't it? What is the value for D? This one. Or 4A square B square C square is equal to lambda A square B square C square. Okay? So from both the sides you can cancel the common term. That is A square, B square, C square gets cancelled. All are 1 here. 0 in you. That means what do we get? 4 is equal to lambda, or lambda is equal to 4. So what is the value of lambda? You have to get the value for lambda, isn't it? Find the value for lambda. So lambda is equal to 4. So that is your answer. So you can copy it. I'll give the homework now. So these are your homework. So exercise 2B, each question carries 5 marks, page number 177. This question is number 27. You have to show that this determinant is equal to 0. That is, what is the first row here? X minus 3, X minus 4, X minus alpha, X minus 2, X minus 3, X minus beta is in the second row. What is the third row? X minus 1, X minus 2, X minus gamma, which is equal to 0. Okay, you have to prove that this determinant is equal to 0. What is the condition given here? Alpha, beta, gamma are in AP. So we have done such type of problem. You can do it at home. So if alpha, beta and gamma are in AP, what can you write? Second term minus first term is equal to third term minus second term. That is, beta minus alpha is equal to gamma minus beta. You can use this condition to prove this determinant is equal to 0. So we have done such type of problem before. Okay. So now this is from HS 2015. These are from HS 2015. Actually, I think you have done it. Again, revise it. Okay. So HS 2015. 1B number 2. Without expanding, prove that this determinant is equal to 0. Thorough without expanding. You cannot expand it. What is the first row? 9, 9, 12. 1 minus 3 minus 4. 1, 9, 12 is equal to 0. Without expanding, you have to prove it. Okay. You have to show that this determinant is equal to 2 into A plus B plus C whole cube. This question is from the book. We have done it. So again revise it. Okay. Prove LHS is equal to RHS. Now 2B number 2. You have to solve for X. Isn't it? You have to solve for X. That means you have to solve it. You have to get the value for X. We have already done this type of problem because this question is from the book. Again you revise it once again because this is quite complicated or difficult problem. Again you can do it at home. बुझ्यौ तिमीले यो प्र्याक्टिस गर्न फेरि पनि गर्न बुझ्यौ छैन जति गर्यो जति प्र्याक्टिस गर्यो जति रिपिट गर्यो तिमीलाई त्यति नै राम्रो हुन्छ ठीक छ So this much is for today. You can copy it and you can do it at home. Okay, so this much is for today. So thank you.